So today, we're going to pull back the curtain on something that's literally all around us all the time, but completely invisible. We're talking about the pushes and pulls that shape our entire world. We're diving into the amazing concept of force.
Okay, let's start with a scene that I bet is pretty familiar to a lot of you. A simple bike ride. Looks pretty normal, right? But this picture holds the key to a question that gets us right to the heart of physics.
You know that feeling, right? That burn in your legs when you start climbing a hill? It's a very real thing. Well, the answer to why that happens, and honestly, a ton of other everyday mysteries, it all comes down to one single idea: force.
Okay, so here's the game plan for our explainer today. We're going to start with the absolute basics. What a force even is. Then we'll get into the ones you can feel, the ones you can't, and tackle some really common mix-ups like gravity, weight, and mass. Let's get started.
First things first. Before we can talk about all the cool stuff like friction and gravity, we really need to get on the same page about what scientists actually mean when they use that word force.
When you boil it all down, a force is just a push or a pull. That's it. But here's the really important part. It always happens because of an interaction between at least two objects. You just can't have a force in isolation. And in the world of science, we measure that push or pull using a unit called the Newton.
So, what's the big takeaway here? Forces are all about change. They're the reason things start moving, speed up, slow down, or turn. They can even change an object's actual shape, like when you crumple up a piece of paper.
Okay, now that we know what a force is, let's start sorting them out. And the first way we can do that is based on a really simple idea. Do the objects actually have to be touching for the force to work?
These are the forces you're probably most familiar with, the ones you experience 1,000 times a day. Pushing a shopping cart, picking up a coffee mug, or, your foot pushing down on a bicycle pedal. All of these require direct physical contact. And maybe the most obvious contact force of all is muscular force. I mean, every time a deer leaps through a forest, a bird flaps its wings to fly, or you just get up and walk across the room, your muscles are contracting to create a force that makes it all happen.
And now, let's talk about the force that always seems to be working against us: friction. It's the whole reason your bike slows down when you stop pedaling. It's a contact force, and its one and only job is to oppose motion. And this is what I think is so cool. Why does friction even happen? Well, if you could zoom in on any surface, even one that looks totally smooth, you'd see it's covered in tiny little bumps and grooves. When two surfaces slide past each other, those little imperfections catch and lock into each other, and that's what creates the resistance we call friction.
All right, things that touch, that makes sense. But now we get to the really wild stuff. Forces that can reach out across empty space and have an effect without ever making physical contact. This is where science starts to feel a little bit like magic.
These are what we call action at a distance forces. They just operate invisibly, exerting their push or pull without anything in between. It's a fundamental property of our universe, and it's pretty mind-bending when you think about it.
And in our everyday lives, there are really three big ones you'll run into. You've got the magnetic force holding stuff to your fridge. There's the electrostatic force, that static cling that makes a balloon stick to the wall. And then there's the big one, the one that's acting on you right now: gravity.
And speaking of gravity, this is a perfect time to tackle a really common point of confusion. We're going to clear up the difference between gravity, weight, and mass once and for all.
You hear it all the time, right? Someone says, "Oh, this bag of apples weighs 2 kilograms. But from a science perspective, is that actually right? Let's break this down, because understanding the difference is key to understanding gravity.
Okay, here's the absolute key difference. Mass is how much stuff, how much matter an object is made of. And that amount of stuff doesn't change no matter where you go in the universe. Weight, on the other hand, is the force of gravity pulling on that stuff. So mass is in kilograms, but weight, because it's a force, is in newtons.
And this chart, it just makes it so crystal clear. Take a look. An object that's 1 kilogram of mass is 1 kilogram on Earth, on the Moon, on Mars, anywhere. Its mass is constant. But its weight, that changes like crazy. On the Moon, it would weigh just 1.6 newtons. But on giant Jupiter, it would weigh a whopping 25.4 newtons. Same stuff, totally different weight.
Okay, for our last stop, let's talk about a force that actually pushes back against gravity, and I guarantee you felt it every single time you've been in a pool or the ocean.
All right, I know what you're thinking. That's a snake on sand. But I want you to imagine a totally different scene. You're in a swimming pool.
Have you ever noticed how you feel lighter in the water? Or how a heavy beach ball is super easy to push under, but then it rockets back up? So what's going on there?
So that feeling, that upward push you feel from the water, that's what we call the buoyant force. It's a force exerted by the liquid that directly fights against the downward pull of gravity. The water is literally helping hold things up. And this all goes back to a super famous aha moment from the ancient Greek scientist Archimedes. The rule is simple. The upward buoyant force is equal to the weight of the water an object pushes out of the way. This is it. This is the reason a gigantic steel ship, which is way denser than water, can float. It displaces so much water that the upward push is strong enough to hold its entire weight.
All right, so let's do a super quick recap. A force is a simple push or pull that makes things change. They can be contact forces, like friction, or non-contact forces that act at a distance, like gravity. And remember, your mass is how much stuff you're made of, but your weight is just gravity's pull on that stuff.
Okay, so let's wrap this up with a little thought experiment to leave you with. We've seen how important all these forces are, but gravity is the one we can never escape. So I'll just leave you with this question. If you could just flip a switch and turn off gravity everywhere for 1 minute, what do you think would actually happen?